All right, welcome to the session 2 of the lecture 10. It is the lecture 10, session 2. I welcome all of you. So let us start the discussion, and the point at where we were earlier. I wanted to tell you this particular important, fascinating point that although we want that the agent should perform the right thing, but sometimes agent may not have a exact representation of the word. It may have a different representation of the word. That's why this particular line is there that tells that word is different and the representation is different, could be different, and most probably it is going to be different. Okay, in this word representation word, our agent is there. Agent inside the agent, when we go inside the agent, this is the scenario where we are. He has some knowledge, and using that knowledge he want to find out some other knowledge. Entailment means other knowledge. So what is the other knowledge? Because some percept is given to him, so he want to derive that, given this particular scenario, what does this percept means and how I should change the things. So therefore, it generates a new kind of sentences that make sense, and in every scenario, it gives the semantics. Means if this is the new scenario, then what is the meaning of all these words? And they are actually somehow their semantics are same. Means if kind of representation into semantic word means understanding of the word, the things are equivalent. Okay. So really, the things goes like this: that initially the word is into some state, and then something happens. Therefore, it follows that the word goes into the different place. And with respect to that, there is a representation that is inside into our word, our things. Okay. Now the question remains. Now the next question that comes to us, that this how to represent these sentences and how to entail on them to come up with the new sentences. Okay. So we are going to see into the detail, and for that we are going to see some formal mathematics here, and for that I think it would not be very difficult. Let me tell you that we are going to see very easy thing in this class. Okay, don't feel burden of the mathematics. I just want to tell you this thing. We are going to touch upon the propositional logic thing. Okay, all these things are taken from a book that is this book, and also there is a Huth and Rayan book that you can also see, and the reference is given into the last slide. That every presentation has the on the thank you slide. There is a reference as what are the references available. Information is provided for that. Okay. So propositional logic says that whenever you are going to provide some information, knowledge, then you should be into the propositions, into form of proposition or declarative sentence, because they are providing some knowledge. It should be a declarative sentence. Okay. And what is the important about the declarative sentence? That either those statements are true or false. So whenever the things are given into fed into the system, they should be declarative sentences, and either they should be true or false. All right. So we are going to see this kind of scenario where the sentences are declarative sentences, and either they are true or false. So let us one by one try to see that whether these statements are true or false. For example, if I say sum of 5 and 4 is 9, so whether this statement is true or not? True. All right. Can everybody write true? Sum of 5 and 4 is 9. Is it true? Yes, it is true. So therefore, it's a declarative sentence. I'm happy with that. Next statement. Could you give me your pen? Is it a declarative sentence? I'm asking a question. Could you give me a pen? Okay. And how can I say that it is true or false? Even if he give me the pen or he don't give me the pen, how does this statement matters? It's not a declarative sentence. It's a question mark. Could you give me a pen? It's not a declarative sentence. Could you give me a pen? Can you tell it was true or false? Because he have given me a pen. This could be true or false. But could you give me a pen? How can it be false? Understand? This cannot be true or false. He have given me a pen. You have given me a pen. That can be true or false. If you have given me the pen, it's true. Otherwise, it's false. But could you give me a pen? Now it's a question mark. It's not a thing. All right. Next question. Every natural number greater than 2 can be written as a sum of 2 prime numbers. What does that mean? Every even natural number. Every even natural number. What do I mean? Do you know natural numbers? Natural number are 1. Natural number are 1, 2, 3, 4, 5, 6, 7, dot dot dot. These are the natural numbers. Okay. Things which are found into the universe are 1, 2, 3, 4. Therefore, they are called natural numbers. I am telling that every even natural number can be written as the summation of 1 plus 1. This can be written 3 plus 2 plus 2. This can be written as 3 plus 3. Okay. So every natural number, if I say 8 over here, every even natural number, how can I write 8? 5 plus 3. 5 plus 3 can be written by summation of only two numbers I am talking about. These are the two numbers, okay, 5 and 3, and they are prime. Okay, summation of two prime numbers. So this is what my point is. Okay, even every even natural number greater than 2 can be written as sum of two prime numbers. So can you tell me it is true or false? True. Okay, people are telling that it's true. Okay, all right. Can you give me the proof? Right? Yes or no? What is the problem? Proof by induction? I would be very happy to see this. Please try to solve this and give me the proof. Okay, proof by induction. You cannot prove this. Okay, very difficult to find out the proof. So therefore, finding out the proof is not known to me. Okay, but we know one thing. Sometimes we don't know that what is the truth condition of this thing. My point is, point I want to make is this, that this is a statement that can be true or false. Are you with me? It may be true or it may be false, but I don't know that whether it's true or false. There could be some scenarios into this particular scenario. I don't know that what is the right answer, whether it is true or false, but I know that this could be true and false only. Are you with me? Can you understand this part? This statement is true or false, I don't know. Alright, I don't know, but it is a statement which could be true or false. So therefore it is a declarative sentence or proposition. This is a declarative sentence or proposition because this statement can be assigned a true or false. But I am not going to prove this. I don't have the proof. But that I don't know. But I know that this can be assigned true or false. Somebody can come. But can somebody come and tell you that what is the true or false? That could you give me your pen? No. Similarly, best of luck. If I say best of luck, true and false. Can you say true or false for the best of luck? Can you tell? No, you cannot tell. So therefore, this best of luck is not a declarative sentence. So here onwards, we are not talking about this particular thing. These things written into the green are the propositions, are the declarative sentences, and at this point onward, we will be only dealing with the declarative sentences. All right. Sometimes it is better to represent them using some symbol. So let's assume that we have two symbols P and Q. P is a sentence. Like, what does mean P? If I say P means what? I won a lottery last week. So is it a declarative sentence? Yes. If you have won last week, then it's true. Otherwise, false. You may be lying. So, but the sentence is I won a lottery last week. That is a sentence, and therefore, instead of writing this complete thing, I have represented this using a single letter P symbol. Similarly, I have purchased a lottery ticket last week. This is again a single next thing. Okay, this is Q. Okay, so you see that if Q happens, then only P can happen. If I have not purchased the lottery ticket, then how can I win the lottery last week? But even if sometime I purchase the lottery ticket, I may not win the last week. Those things are now you can see that there is some dependence between the symbols. So I am going to represent a particular declarative sentence with the symbols. Okay, so now onwards we will be only talking about the sentences. So what does it mean whenever I am telling the P or Q? So what the P and Q can have the value? They have the value true and false. All right. So you can form sometimes the complex sentences using some negatives. For example, if I put minus, then it's become negative. If I put caret, so with, then it becomes a disjunction, or the at least one should be true. Then we have V sign, that is the conjunction sign, and then we have an implication. So these things we can apply, and we can see that there is some relationship. Okay. All right. So what is the negation of this thing? If I say that P and if I say that not P means what? What is the not P? If I say P, you know P, na? I won a lottery ticket last week. What is not P? So since you can very simply write this statement that it is not true that I won a lottery last week. Okay. If you say that I didn't win a lottery ticket last week, that is also perfectly fine. But the better way is this, that it is not true that I won a lottery last week. Sometimes, because this statement can be very complex statement, and if you buy yourself, because when you say the complete statement such as I didn't won a lottery ticket last week, then it's a kind of right sentence. But maybe if this statement has been a complex statement, then the different meaning can come out. You should be very careful about that. So therefore, the better way to write is that it is not true that I won the lottery ticket last week. Now it's fine. It's fine. So negation means it's not true that I won the lottery ticket last week. Similarly, not Q means it is not true that I have purchased a lottery ticket last week. That's it. And P and Q means what? P and Q means what? It's a disjunction, means and operation. Both the things should happen. Okay. I think I have written wrongly. Conjunction. This would be conjunction. This would be disjunction. Okay. Conjunction means you're concatenating. I think there is a typing mistake. Okay. This is the conjunction. Conjunction means both the things. P and Q means what? I have purchased a lottery ticket last week and I won a lottery last week. Okay. So this is and operation. Conjunction. Both should be true. I think there is a typo mistake. I'm just pointing out this. By yourself, please correct. So this is a typing mistake over here. So we should take care of this, okay? Because typing mistake would be there. I'm very sorry for that, but this has been happened. You know what is R? If I put here, I won a lottery ticket last week, or I have purchased a lottery ticket last week. Both can happen, okay? Or at least one should happen. Implication. Q implies P means I have purchased a lottery ticket last week, therefore I won a lottery ticket last week. P implies Q means I won a lottery ticket last week, therefore I have purchased a lottery ticket last week. So this is the implication. Okay, you see the implication. All right, so it is better to see the truth table. That is not a new concept for you. Truth table means provided some of the value, you want to find out that what is the truth of this particular value. So, okay, all right. You see this value P and Q. So these are the two variables that we have. P can have true, false, false, true, and false, false. All right. These are the four positions possible. If we have two statements, then P and Q, how many combinations are possible? True, false, true, false, false. Not of P is false, true, true. Is it? Do you understand this? Should I explain more? Do you understand this? I think I didn't have to explain much now. You know this. Should I tell you? Yes, we understand. Okay, right. So this thing you know that not of P, and you know what is and operation, that both it is true when. Achha, I think you understand this, but I think I should give you the right definition for this. Okay, so what is definition? What is the right definition of and? What is the right definition of the and? What is the right definition of and? Definition is true if both true. This is what it means. Okay, true if both are true. Do you see that when both are true, at this position only they are true, therefore it is true, otherwise false. Okay, so you can write only true if both are true. Both are true. This is what it is. Okay, what is PRQ? Okay, only false if both are false. You see, this is the definition. Okay, this is the false when both are the. Oh, sorry, I think I'm not here. I should tell. The both are the false, then it is false. Okay. P implies Q. Okay, this is important thing. That's a very important thing. It actually says if P then Q. Okay, if P then Q. Or here the condition is very different. Okay, what is the problem? If I say that if this is true, when this statement is true, this statement is true. That if this is true, then this should also be true. Okay, the only thing is required that when this is true, then this should also be true. If this is true and this is false, it is bad thing. It is bad thing. It should not happen. If it is true and it is false, then it is false. Then only it is false. Okay, then the statement is false. Otherwise, if this is false, what would happen? Interesting condition comes when this particular thing is false. When this is false, this is false or this is true. In both the cases, this statement is true. What does it mean? You understand? Why it is true? In these scenarios, why it is true? If the main condition is false, why it is true? Okay, so this is the trick table. Looks like that if somebody says that I can eat the moon if you can bring the moon on the earth. If I say that I can eat the moon if you bring that moon to the earth. So I'm not eating the moon, but I'm true because you are not bringing the things on the earth. If you bring the moon on the earth, then only I can eat. So therefore I'm not wrong because you have not tested me. If you tested me, means if you bought the things on the other thing, you are true. Then I have not eaten, then I'm false. When I'm false, that if you bring the moon on the earth and I'm not eating this, then only I would be false. Otherwise I'm true. So safely, this is a very interesting scenario that when the P is false, then in all the cases it is true. Okay. Similarly, next thing is the double implication that says that P implies Q and Q implies P. So it means that now both the sides would be same. So now therefore it is both the side because it's and P implies Q and if both the things are similarly, you can apply the same thing from P implies Q over here and you see that the two false are there, otherwise it's true. Any more question? I think you have understood that this is the only important part that I want to tell you, that this is very interesting, that how come here both the things are true, and if you have any problem you can ask the question, otherwise I assume that you understand this. Okay, all right. So what is the natural deduction? Okay, this thing we are going to get is a little bit technical. So suppose we have these formulas phi1, phi2, phi-n. The formulas means some sentences or some knowledge. These knowledges we have, and we have applied some proof rules to get another formula phi. And what are the proof rules? We'll be talking about that. What are the valid proof rules that you can apply? Then we can denote that phi1, phi2, phi-n are actually giving you this psi. Okay, they are deriving the psi. So you understand this thing, that these are the facts that you have, and then you have applied something, then you got the psi. From the various phi's you got the psi. And this thing in total means these thing is actually applying these thing on using these things we can find out psi is called the sequent. Is a sequent and is valid. This sequent is valid, means this thing is valid. If when it is valid, if you can find out a proof. So can you understand this? Should I go ahead? You understand this now? That we have some knowledge available, and we have applied some proof rules, and then we have got psi. And now phi we can write it in this way. This is the sequent. This is called this thing. When I write it like this, I say that this is a sequent. This sequent can be valid or invalid. This sequent is valid if I have a proof, because my assumption is this, that I find out psi using some proof rules. So if I have some proof rules, then I'm done. Otherwise, I'm failed. So are you okay? Should I go to the next slide? Is it clear? Is it clear? Can anybody write yes? Do you need more explanation? Not clear? Okay, no, please. Somebody is telling not clear, but please continue. No, please don't let me continue because I'm here for you only. Okay, here I'm not to understand myself. Let me tell you one thing. That let's assume that you have some information. Are you with me? That let's assume that you have some information available, and now using that information, if you apply some proof and got something psi, this can happen, na? You understand? Okay. Do you understand this or not? Just tell me that. Do you understand this part? You have some information, you have applied some rules, and therefore you find out some this for something new. Whatever information you have, you applied something. You means you have mixed match something, and you find out some new formula. This can happen. Can you write yes? Can you write yes? Okay. Correct. You have some information. Means these files are with you. You applied mix and buff proof, and you have come up with this particular output. And this is you come up with the right thing. If you have come up with the right thing, the point is that if you have come up with this psi with the right kind of things, then you have a proof because you can tell I can apply these things, and then I would be able to get the psi. So this, if you have applied the right things, then you would have a proof. And if you have a proof, then this thing is a valid. This thing valid, correct? Because you have a proof, therefore this thing is a valid. Overall, this thing called a sequent means using these things I am going to get thing. That's fine. Okay, clear? Should we go ahead? Now this is one rule. This is one rule for the conjunction. Okay, what is the conjunction rule? If you have phi and if you have a psi, you can say we have phi and psi. Is it difficult to see? Is it difficult to see? See this part only. Only a valid sequent will be present. Isn't it, sir? My question is, valid sequent would be present ऐसा नहीं है. Anybody can give me any false thing, but the point is, for that you cannot give me the proof. For the valid sequence, you can give me the proof. For the unvalid things, because anybody can come up with any kind of rubbish, but for those things, there would not be any proof. Okay, valid sequence are sequence which have the proof. That's it. Clear? Now let's understand this thing. That's very easy thing to understand. If you have phi and if you have psi, then you can say I have both phi and psi. Is it clear? Is it clear? Just understand this. And this, what is this? An introduction means how to I can introduce this. If two things you have, then you can write like this. Correct? You can eliminate it as well, because if you have phi and psi, then you can say I have phi. ठीक है, I have. I have a pen, I have a sketch. I can tell them मेरे पास sketch pen. I have a sketch pen. That's fine. If I have phi and psi, you can say I have psi. Similarly, as you take the first thing, you can take the second thing. So if you take the first thing, I say even elimination of one, elimination with one, E2, elimination with the second item I had taken, first one eliminated. Clear? Very simple thing. Okay. If somewhere you find out that somebody write the phi and psi, you can take any of them. So you can, as a conclusion, you can take it. What does that mean? So mean ये है कि P and Q and R, these things are given. What are the two statements? P and Q and R, and you have to come up with P and R. Can you come up with this? आइए देखते हैं. Let's find out this. How can we do it? Okay. So what is given? Two sequences are given to me. Okay. Okay. What is this? P and Q. P and Q. Okay. What is else is given? R. Small r. Okay. Small r. R is given to me. Sir, is this a derivation? Yes. This is a kind of derivation or proof. Okay. P and Q. Okay. This is, what is this? This is premise. Something is given to me. R is something, it is again premise. This is again given to me. What I can find out? I can, since P and Q is given to me, I can say Q is given to me using this particular formulation, using this and of E1, I think E2. Okay, this would be applied. Okay, are you with me? This would be applied now because P and Q given, I am taking Q. So it is and of E2, right? And now R and Q is there. So R and Q is there. So what I can write? I can write the Q and R. Q and R is with me. I can write Q and R. I can write like this. Similarly, using these two, I can write Q and R. Okay. And here I have introduction of I have placed. Now I got the answer. You see now how we have come up with this solution. Okay. Can you see this? Simple. You know that this is given to me, R is also given to me, then you can find out Q because of Q is there, E2 of on 1, on line number 1 if you apply Q, you find out this, and then since these two things are there, you can apply introduction and introduction give you this thing, right? Alright, easy? Okay, I have a question for you. Can you solve this? Can I solve this? Let us try. Okay. So let me just take it. Let me just take it here. Control Z. Let me just take it here. I want to give this. Remove all other things. Okay. Okay. So what is given? Just tell me. It's very simple, na? Very simple. Very simple. So this is given to me. This is what is given to me. P and Q and R is given to me. Okay, so we call it premise. This is premise for me. Second thing is this. S and T is given. This is also premise. I want Q and S. Okay, so how can I find out Q and S? Because S and T is given to me, so I can take S by first part by E2 by E1. And this using this thing I can find out S. Acha, Siri is asking that, sir, you please explain the first rule. This rule, if two things are given, then you can write because you have mango and you have apple. You can say I have a mango and apple. That's very simple. As simple as that. If you have mango and apple, you can say I have apple. Mango and apple, you can say mango. That's right. Simple. Okay. Somebody is writing a minute, sir. What do you want to ask? Markande, do you want to ask a question? No? Should I continue? Just wanted to say that I will solve. Okay. You would solve. Okay, that's it. Please continue. Go ahead. Okay. No issues. So just see me that just see these things are here. So if you say that I can also stop solving those things. So there later point of time there will be some question. Just solve this thing. Okay. So can you suggest me that what should I do? Because I want to find out Q and S. S is with me. Can I find out Q? If I find out Q, my things is done. Where is Q? Q is inside here. So therefore these two things are there. Therefore I can write P and Q. Using this I can write this. What is the thing? I have taken the first part again even. Okay. From this thing I want Q, so therefore I can apply E2. Okay, elimination of E2, I got Q. Now I have S and Q both available. I can say that I can use the introduction rule on S and Q to get S and Q. But I need QS. That is fine. Q and S and Q are same. Okay, using this introduction rule. So alright. I have somebody has written, Akash has written a question, sir, how P and Q correlates to S? Okay, this is the question, Akash. Do you got the answer? No? I say that how P and Q correlate with S. They are not correlated. Okay, the question is they are not correlated. They are all independent. But if we find out that in the process there is something that can connect, okay, then we are done. Okay. So Akash, I don't know that at what point you have the problem. So can you tell me one thing, that do you, one by one please tell me, Akash, huh? Tell me, do you understand this formula? Are you with me? Yes? Do you understand this formula? Second formula? Yes? Do you understand the third formula? Alright. If you understand all these formulas, then my work is done, because what I would tell, that these two things are given to me. P and Q and R is given to me. What does it mean? I am given P and Q and R. I can take it out. Okay. I can take P and Q. I can take R. P and Q is given. I can take P. I can take Q. I can take R. I can extract all these things and say that I have P, I have Q, and I have R. Similarly, from the second thing, I can say I have S and I have T. Okay. If all the things are there as an independent entity, then I can say that I have S and T, because what is the problem? S, Q, and S. So if somebody asks me that give me Q and S, so I say that Q and S is with me. I can combine them and I can write that Q and S is there. So this is how you see that given some information, you see that these things are there. Okay, these things are the representation, and then using them you can find out another sequence. That is also true. Now, do you understand? Do you have any questions, Akash? Hope you understand this part. Okay, Akash, do you understand this part? Understood? Thank you very much. Means given all these things, you actually try to see that what all things you have, and then using those things you can combine and you can find out the solution. That is on you. All right. Okay. All right. So this is, we have seen that conjunction. Okay. Next thing is the double negation. Okay. If you have phi, you can say not phi. Not phi means, let's phi is I have 100 rupees. What is not phi? It is not true that I have 100 rupees. What is not phi is? It is not true that I have 100 rupees. What is not true? It is not true that it is not true that I have 100 rupees. It means that I have 100 rupees. Understood? The double negation means positive. So this is how introduction of the double negation. If phi is there, you can write not phi. If not phi is there, then you can write phi. It is elimination of the double negation. All right? Is it understood? If somewhere you need, you can utilize this. Is it understood? Yes? All right. Now my question is, can you prove this? Okay. Can you prove this? Can you prove this? What is given to me? P is given to me. It is premised. What is not of Q and R is given to me. This is also premised. Okay. Then I can apply this thing. This double negation elimination. This thing I can apply. This thing I can apply. And what I would get? Q and R. If Q and R is there, I can get Q, I can get R by elimination. Okay. And elimination E1 and elimination E2. Okay. These things are given to me. Now I have P. P is available to me. So I can utilize the introduction of I, this thing over here, to say that with this P I can say not of P. Okay. Now I have two things. What? Not of P and R. So I can combine them. How I can combine? That not of P and R. Okay. What is this? Introduction of and introduction. So I got this thing. This is what the proof is. All right. See this. This is what the proof is. that this thing was given, then you have to take for the P, it is not P, and from this thing you can Q and R, and then you can find out R, and then you can write it like this. All right. So next thing I want to tell you that this is another rule of inference. What is the inference rule? Phi is given to you. Somebody tells that phi implies psi. Then you can tell psi. Is it right? Is it easy? Phi is there, and somebody tells that phi implies psi. Then if phi is you have and phi implies psi you have, then you have psi. What does it mean? It means that I tell you that if you can get 50 marks, you would pass. Okay. This statement is phi implies psi. If you get 50 marks, phi is if you get 50 marks. Okay. It's not very difficult to see. Very easy. Let me tell you this thing using an example. Let me tell you that what is phi. Till phi is equal to if you get 30 marks. Okay, you get 30 marks. If let me remove. You got 30 marks. This is the statement. Okay, phi is you got 30 marks. Okay, and psi is you are pass. You pass the exam. You pass the exam. You pass the exam. Okay. Phi implies psi means what? If this you get 30 marks. If you get 30 marks, then this thing, second statement, you pass the exam. Understand? Now I tell you further information that this is what you know, na? Phi implies psi, you understood that what it is. Now I give you this particular thing also true. This I am giving means this is also given to you. This is given to me means statement is given to you means it's true. Then only it is given to you, na? What does it mean? You got 30 marks is true means you got 30 marks. This is also given to you. And two statement is there. You got 30 marks. Number one, you got 30 marks, and another, if you got 30 marks, then you are pass. So my question is that if these two things are given to you, it means that you pass. You pass the exam. Correct? All right. So this is not difficult to see. This is very easy. So let me just take this. It is going. Let me come here. Control V. Now I want to find out this thing. Can you show me? Can you help me to solve this thing? Okay. What is given? P is given. Premise. P implies Q is given. This is also premise. Then 2 times y it is P. Another statement is P implies Q implies R. Okay. You have to infer R. Means you have to, this thing is R. This thing is R. Okay. So this thing is also premise. Now you have to infer R. So can you infer R? Let us see. Since P is given and P implies Q implies R, it means that Q implies R is available to you. This part is available to you. Since P implies Q is there and P is there and P implies Q is there, it means that Q is implied available with you. Okay, using these two you can say that Q is available to me. And third thing is Q is available to you, and Q implies R is available to you, therefore R is available to you. Okay, so therefore you got R. Correct? All right. So this is how we prove this. And then there is a very important thing that is called the modus tollens. And modus tollens says that if phi implies psi and not a phi is there. I think again there is a typing mistake. Not of phi, not of psi should be there. Okay. Not of psi should be there. Okay. This is again a typing mistake. Let me just tell you what it is. Okay. Because I am typing everything by myself. I'm sorry for that. That any other time I do these mistakes. So what I want to say that that this particular part, okay, this is not of psi. Okay. So what is this? Phi implies psi, but the psi is not there. What does it mean? Both the two things is given. It means that not of phi. Again, because if phi was there, then it was you have got the psi. But since you have the not of phi, it means that not of phi is there. Okay, you understand this thing. So this should be not of psi. Okay. So this is called this particular proof rule has a name, big thing, because it has a name. No issue, because we know that it's not very difficult to see. Okay, can you see this easily? Because if phi is there, then there would be psi. But not of psi is there. What does it mean? Not of psi is there. It means that phi is not there. It means not of phi. That's it. Very simple. Okay. So can you show this thing? P implies Q implies R, and P and minus R they imply minus Q. Can you show this? I'm not going to solve this. It is for your homework because you want to work it. So you work by yourself to find out the solution. All right. That's it. Now the very important part and the very interesting thing is this that I want to tell you, and it is very interesting, and I am going to tell you that in this way that you'd find it very unique thing. You see, this is a box. What does it mean? Anything you can assume. In the box this is your word. Okay. In your word, if you start by phi and you get psi in your word, because outside since it is inside box, then whatever happening over here is not as valuable from outside. If in your box you start from the phi, you get psi, then you can say that phi implies psi. Okay. बड़ी विचित्र बात है. It's very विचित्र. Means phi implies psi, and everything is in your word. Some information is given to you, then that information would also make your life hell. But if it's not like that, to show that this is true, Q implies R implies not of Q implies not of P implies R. I don't know what is going to happen, but I have to show this. If I want to show this, what should I do? Very difficult. Just see that how unique this kind of scenario is. Okay, implication introduction is how unique it is. So here you can identify two parts. Number one, because wherever there is a implication introduction, there is one part phi and one part psi. So which part is phi? Which part is psi? Can you tell me? Okay. So here you see that this part is phi and this part is, because this bracket from here to here, na? So this part is psi. Okay. So how can this be proved? If you start by Q implies R, and in itself you do something, and you reach to this particular thing, minus of Q implies minus of P implies R. If you reach to this particular conclusion, okay, if you start by this, this can be your assumption. Okay, because it is inside, then it is not affecting anything outside. So if you can reach to this particular point, then you can say this line, because directly you can write like this line. So do you understand this part or not? If you understand this, then I'm done. Can you understand this part? Yes. Phi, from the phi you go to the psi. How you come up with the phi? You can assume, because it's inside the box. So it is your word. You can assume anything. If you assume something, you reach to the psi, then you can write like this: phi implies psi by the introduction of implication. Is it clear? So if I want to show this thing, so I have to somehow find out Q implies R. Means you can assume inside, and you do something so that you reach to this particular point. That's it. If you reach to this particular point, everything is right. All right. Let me go there. Let me try to see that how I'm going to put. So this thing I told you, that inside your word, inside your closed word, if you start by Q minus Q implies R, and you somehow come up with the solution that minus RQ minus implies minus R and implies P implies R, then you can write like this. Okay, so I'm going backward. Okay, all right. How can you write like this? Again, the same thing you can apply now, because if you start by minus Q implies minus R and you could reach P minus R, you start by this, then you can write like this. And that's this part. First part you can assume, because it is inside the rectangle, therefore it's your word. Inside you can assume. So inside something, again there is another assumption. You cannot remove this thing, because if anything it is true inside, it may not be true outside. So you have to put every time you have to put square box, rectangular boxes. All right, how can I reach from here to here? Again the same thing, P implies R. How can you reach? If you assume P and you reach to the R, then you can do it. Okay. All right. You can write P implies R if you start from P, that you can assume, and then you reach to the R. How can I reach from here to here? So let me just see that since you have the P, now at this location you have P. You can write not of P and not of Q. How can I write not of Q? This is empty of 2 and 4. 2 and 4, because not of P is there. Okay, and not Q implies not of P. Okay, just see this. So let me just take it out and let me put it here, because only this much mathematics is there, not more than this. Everything was actually mechanical. Only this part is there, that since you had a P, then you can write like this. Okay, now you have not of P. So and also you have two statements. This statement you have, that is minus of Q implies minus of P, and you have not of not P available. If not of not P is available, not P is not available to you. Not P is not available. Not of not P is available. Again, you can apply the modest tolerance, because A implies B. If it is like that, if A implies B is there and minus B is there, and here what is minus B? It is minus of X can be there. Na? You can say B is minus of X, minus of X. You can assume A implies minus negation of X, and negation of X is there. Okay, similar thing is there. Okay, then you say that negation of this thing is there, means minus of A is there, but here what is the A? It is minus Q, so you get minus of Q. This is overall the main thing that is happening over. Minus of Q is there. If minus of Q is there, then Q is there, because minus of Q is Q. If Q is there and R is there, starting from P you reach to the R, then you can write P implies R. Either this part is solved, this part is solved. If this part is solved, then everything is actually inside, placed in such a nice way that everything is solved. All right. Try to see this. It's a very simple example, and similarly we have 3 more examples for you. P and Q implies R, and then you want to prove that P implies Q implies R, and similarly these 2 more things I have. So I think that we have gone quite well in this class, and I am very confident that confident that you would be able to by yourself able to show this. In case you have any problem, then please shoot a mail to me so that in the next class I can include this thing once again, and in the future classes we would be actually doing something more. Okay. So any more questions? So that's all for today. So these two books are there. They are told. Thank you very much. These two books are there. You just try to see them and get the understanding that what we have discussed today. Okay. So there's a question just so previous slide for a moment. This would be for you. Acha, you want to note down? Okay. All right. You can note down this. All right. So any more questions? No questions? Hope you enjoyed this lecture. Thank you very much for being with me. Bye.